Data on frequency. Again, this is the frequency architecture series part 4. So hopefully you've enjoyed the previous parts of the series. This time around, we're going to dig into data and how exactly that data ends up being stored on frequency, what's being stored on frequency, what's the flow, how does data get to frequency. And the best way to kind of start these discussions off is by following some journeys of data, right? So sign up is a great example of one of these journeys that you can follow. And, it starts in a very traditional way. A user goes and starts looking at an application's user interface, right? And that interaction is a very traditional one. It may even start uh, with a, sign in with continue with frequency button. um, but at the end of the day, what the user is actually doing to kind of represent themselves, the data that represents their control and their understanding, is a private key. So frequency, like many other things, uses a public-private key pairs, this asymmetric cryptography, to be able to uh, programmatically show security and safety. This is the same technology that a lot of newer things are using now. Things like, if you've heard about passkeys and things like that, it's using a lot of the same technologies underneath the hood. So there is that kind of private key. It's often stored in something that's technically called a wallet, but that's just a technical case. And the application, right, that UI has to get authorization to do things. And so it has to talk to that wallet. Sometimes this is through tools such as uh, the sign with frequency standard or frequency access. But that application effectively goes, talks to, it doesn't actually get that private key, but the private key will generate a signature over some data or multiple signatures and collect those signatures as a way to have provable authenticity that this private key that the user has is acting and approving these actions that it's signing. So as after that application UI collects those signatures, after it gets those signatures in some way, it'll pass them off to a backend, which then is going to actually talk to the blockchain itself to actually interact with and do actions with those authorizations. So that's using the capacity methods that we've talked about in the last frequency architecture series. So that backend has its own private key that's actually saying, yes, it's okay to spend the refillable capacity on doing these actions on behalf of the user. But the fact that the user is able to, the fact that the application is able to do them on behalf of the user is because of that signature that the user has given to the application, that proof of authorization. And that on the blockchain itself is going to do things such as create a user identifier. It's going to update the delegation storage. And potentially, depending on whether it's a sign up or just a login, or if it's the first time a user's been to that website, or if it's a new website when they already have a frequency account, frequency is going to end up with some levels of these things. So it's going to create that unique 64-bit identifier. Again, harkening back to the previous uh, frequency architecture series, that's that unique key, the unique identifier for the user on the chain, and it's completely controlled by that user's key. So nobody can do anything without that user's key authorizing it. The second thing that's going to usually happen is it's going to create a delegation. That's what's connecting that application to what the user says that application can do on its behalf. It's that key piece between those two that says, yes, you can do it. And the user, with that user's key, always has the ability to revoke that delegation with at no cost. And that delegation is that bit that's going to come back again as we look at other actions that the user and application can take. Often when the user's signing up, there's also a claiming a frequency bit. This a handle is a combination of a user selection and a unique suffix. And that handle, that specific handle, is signed off by the user. It's one of those signatures, one of those authorizations that the application is getting. And the user saying, yes, I want this. And it's explicit that that's that one thing. There's no the application can't change that handle, and the user is always going to get that same that handle that they signed off on. And finally, we'll see this again in a minute, but a public graph encryption key, right? So as the user's signing up and setting things up, if they're wanting to have a encrypted graph, there's a the public key for that graph encryption is being added to the user-centric storage and signed off on by the user again. So here's kind of that whole flow, right? Again, the user has that secret key held in that wallet. That's that kind of core piece of their identity. And there's interactions with the application UI. The application UI is getting that authorization from the wallet via a signature. And then that data is going to be applied to the blockchain as the user has authorized. And then that data from the blockchain is going to flow back through the back end and potentially to the app ID, app UI, and over to the user where they can see what actually happened. So that's just sign up. There's a lot of kind of moving parts for that. But things get a little bit, in some ways, a little bit simpler after the sign up. So we can follow another journey of social graph, right? This is the user-centric data that is on chain, connected to the user, and it comes in a little bit of a different way, right? So you remember on that previous diagram, we had the delegation storage and kind of that authorization. That delegation storage can include a piece that says, hey, I authorize application X, I authorize them to be delegated to be able to write to my social graph, my encrypted social graph on chain. And so, it starts again in a very normal way. The user and the application UI have an interaction. The user maybe says, hey, I want to make this change to my graph. I want to follow this other user. The application's going to talk to its backend, and it's going to go take a look at the graph storage, right? That's relatively straightforward, except remember, we always say that most of the graphs that are on chain right now are all encrypted graphs. And so it takes a little bit more. So we can actually zoom in a little bit and see there's actually this public graph encryption key. Remember, we added that during the signup process. And the backend is going to take that key and it's going to encrypt all of the changes in the social graph. And then it's going to apply those to the graph storage on the blockchain. And as a little technical note, it's paginated. So if it gets too large, your graph gets too large, it may have to split across multiple blocks of data. That's a very common thing to see in a lot of the chunking to be able to know how much data is where. And so again, we can look at frequency. Again, it already has that delegation, that application to user permission on the graph. It has that current public encryption key, and it has the encrypted graph page or pages that the user needs. And so here it is, kind of that overarching look at all the different actions that flow to update and create a graph on the application. Again, there's over 900,000 of these users that already have these on chain. So this isn't theoretical or anything like this. That's 900,000 of these already happening on chain. But we can also look at the other side of this, right? So writing to the chain, creating a graph is one thing. Let's read it back out. So again, here the user has in their wallet, they have this graph encryption key. So the wallet being kind of where you store the name for where you store all these keys. And the user is kind of going to interact with maybe a different application, go to their UI, say, hey, I want to, the application says, hey, do you want me to show you your graph? And so at that point, the backend is going to go out, it's going to get all of those pages, it's going to reconstitute those pages, and then it's got to do the decryption step. And in order to do the decryption step, the user has to actively give the graph encryption key to be able to decrypt. It has to give that to the application. If the application doesn't have that key, it cannot read the data of the graph storage. So the user has to actively give that. There's in the sign with frequency flow, in the specification for sign with frequency, there are options to ask the user for it and to pass it back. But the application is going to use that to decrypt the graph, constitute it into its readable form for the user, and display it to the user. So again, on the frequency, there's nothing has actually changed as to what's on frequency. It still has that same set of data. It's just reading it off. But the application is a little different, right? It has to receive that graph encryption key from the user, and it can decrypt the graph pages then and combine them and then use that decrypted graph to offer services to users such as, here's the feed of everyone you follow, or hey, you want to look up who's on your graph or see other information about them that the application has. So this is only part one. We've got a lot of other parts to go through. But so next time, we're going to talk more about the data on frequency with the Frequency Architecture Series. Part 5, we'll go into what does time-centric data look like. All of the graph data there was attached to the user. We'll look at kind of what does off-chain data look like. And we'll talk about kind of the system called schemas that powers all of these different types of data being possible on frequency.